We're going to start now section 4.3 on page 303. It's about solving system of linear equations by the addition method. So this is one of the most important methods to solve linear system because the procedure is used to create algorithms to use computers to solve a very, very complicated linear systems with more than two linear equations, with hundreds of linear equations. The system is based on the solutions are based on the addition method. So to work on these systems, we need to write a system we're using the standard form for the linear equation. So that's the first step. So we need to have the equations in this way. Then we're going to eliminate one of the two variables. We can either eliminate x or y. And we're going to do that just by adding the two equations. When you add the two equations, you should be sure that you end up with only one variable. So sometimes you just need to add the equations and that's it. Sometimes you need to multiply one of the equations or both equations by different numbers in a way that you're going to get one of the variables with opposite coefficients. So if you have, for example, here 3y and you get negative 3y here, then you can eliminate y. Then after the addition, you're going to get a linear equation in one variable. So you're going to solve for the remaining variable. And then you're going to do the same thing that we did with the substitution method. We need to substitute the numerical value obtained in the last step into one of the original equations and solve for the other variable. And then we need to test the solution at the end. So I'm going to solve 3 problems for you to see the method, and then you're going to have the chance to work to solve some linear systems by using this method. So I'm going to start with example 1 on page 304. I'm going to solve by addition the following system. So I have x plus y equals 4 and x minus y equals 6. So I have my equation 1, I have my equation 2. And you can see here that, for example, the variable x has coefficients 1 and 1, so it's the same coefficient. And the variable y has coefficients 1 and negative 1. So in this case, you see that one of the variables already has opposite coefficients, and that's the variable that we're going to eliminate because it has opposite coefficients. So y has opposite coefficients in the linear system. So we can eliminate y by addition. So by addition of these two equations. So let's do that. We're going to do it in the next page to see all the problem on one single page. So this is going to be my system. So I have x plus y equals 4 and x minus y equals 6. So I have my two equations there. So now I can add these two equations. So we're going to get x plus x. It's going to be 2x. Y and negative y, they cancel to each other, and this is going to be equal to 10. Then we're going to solve for the remaining variable now. So this is the second step. We have just 2x equals 10. We're going to divide by 2 both sides of the equation. So we're going to get x equals 5. Then we're going to do a back substitution. We're going to do back substitution in one of the original equations. So I'm going to evaluate one of the original equations. So for example, I'm going to use equation 1, x plus y equals 4. and I'm going to evaluate this equation for x equals 5. So what I'm going to do, I'm going to replace x with 5. So I'm going to get 5 plus y equals 4. So I only need to solve for y now. That's the next step. Solve for the remaining variable. So in this case, I'm going to subtract 5 from both sides of the equations to isolate y. So I'm going to get y equals -1. So from these two values, I can get the solution 5, -1. And then you're going to test the solution. So you need to evaluate both equations for x equals 5 and y equals -1. So let's work now on example 2 on page 304. We're going to solve by the addition method the following system. So we have 3x minus y equals 11, 2x plus 5y equals 13. So we have equation 1 and equation 2. So now you can see here that x has coefficients 3 and 2. They are different, but they are not opposite. You have equation, you have for y coefficients -1 and +5. So again, you cannot eliminate any of these two variables just by adding the equation. So we need to multiply one of the equations in a way that you're going to get one of the variables with opposite coefficients. Usually you're going to look for a variable with coefficient 1 or -1, 1 or -1, because that means that that equation can be multiplied to get the opposite coefficient. So you can see here that if you multiply equation 1 by 5, we're going to get -5 as coefficient for y, as the coefficient for y. So, and that is going to be the opposite of the coefficient of y in the second equation. So let's do that. We're going to multiply 1 by 5, and this is to eliminate y. So because we want y to get opposite coefficient. So I'm going to multiply the first equation by 5. We need to multiply both sides of the equation. So this is going to be 15x, and this is going to be -5y, and this is going to be 55. So this is my first equation now after multiplying the equation by 5. Now the second equation is going to be 2x plus 5y equals 13. So that's the second equation. So this is from 1, and this is from 2. So now we can add these two equations. So if you do that, we're going to get 17x. We eliminate y, and 55 plus 13 is going to be 68. So this is my linear equation that I need to solve to find the value for x. So we're going to solve for x here. We're going to solve the linear equation. So we have 17x equals 68. We're going to divide by 17 both sides of the equation. So in that way, we're going to get x equals 4. Then we're going to do back substitution into one of the original equations. So we're going to evaluate. I think we're going to use the first equation, 3x minus y equals 11. We can use the other one, and we're going to get the same result. So we're going to use the first one, 3x minus y equals 11. And we're going to evaluate that equation for x equals 4. So we're going to replace x with 4. So that is going to give us 3 times 4 minus y equals 11. That's 12 minus y equals 11. We're going to subtract 12. So we're going to have here 12 minus y equals 11. So I'm going to subtract 12 from both sides of the equation. I'm going to get the negative y. Don't forget that in this case, y has a negative sign in front of it. And 11 minus 12 is going to be negative 1. Then we divide by the coefficient. The coefficient is negative 1. So we divide both sides by negative 1. So we're going to get y equals positive 1. So now I have my two values. I have my x and I have my y. So the solution is going to be a point with coordinates 4, 1. And you're going to test the solution. So let's work one more problem. So I'm going to work now example 3. On page 305. So we're going to solve by the addition method. The following system, we have 3x plus 2y equals 48, 9x minus ay equals negative 24. So I have equation 1, I have equation 2. So now you have a variety of coefficients for x and y. So we have many options. We have two options. So one, to eliminate x, if you want to eliminate x, you need to multiply equation 1 by negative 3. Why? Because if you multiply by negative 3, you're going to get negative 9, and positive 9 are opposite. And negative 9 and positive 9, they are opposite coefficients. Or the other option is to eliminate y. We're going to multiply also the first equation, but this time by 4. Because if you multiply this equation by 4, you're going to get 8y, and you have already negative ay, so they are opposite. That will be a way to eliminate y. So you have to decide. So it's going to be up to you. So I'm going to work on the first option. You can work the second option at home, and you're going to see that you're going to get the same result. So we're going to work these options. We're going to multiply equation 1 by negative 3. So I'm going to have negative 3 that multiplies 3x plus 2y equals negative 3 that multiplies 48. So we're going to get, applying the distributive property, negative 9x, negative 6y, and this is going to be equal to negative 144. So this is the equation that results from working on equation 1. From equation 2, we only have 9x minus ay equals negative 24. So I have now my system here. So I'm going to add those equations. So we're going to add these two equations. So we're going to get negative 6 and negative 8 is going to be negative 14y. And this is equal to negative 168. Then you just need to divide by negative 14 both sides of the equation. So we're going to get y equals 12. You can use your calculators. So in the next step, we're going to do back substitution. We're going to do back substitution into one of the two equations. So we're going to use the first equation again. So we're going to evaluate 3x plus 2y equals 48 for y equals 12, which is the value that we just found. So we're going to replace y with 12. So that gives us 3x plus 2 times 12 is going to be 48. 3x plus 24 is 48. We subtract 24, so we get 3x equals 24. We divide by 3, so we get x equals 8. So now we have a solution. So we need to test the solution, which is a point with coordinates 8, 12. So that's what we need to know about the addition method. So now I'm going to give you some problems. Let's see. Yeah, I'm going to give you some problems to work on. Then I'm going to solve one or two more problems by using the addition method. So these are the problems that you're going to work. They are from 4.3 exercise set on page 310. So there are many systems. It's important to work in as many as possible. So I have x plus y equals 6, x minus y equals negative 2. Then I have 3x plus 2y equals 14, and 3x minus 2y equals 10. And we have 2x plus y equals negative 2, negative 2x, negative 3y equals negative 6. Then problem 8, we have 7x minus 4y equals 13, negative 7x plus 6y equals negative 11. Problem 10, you have 3x minus y equals 11, 2x plus 5y equals 13, and finally problem 16, you have 5x minus 4y equals 19, and 3x plus 2y equals 7. So at least work on problems 16 and 8. These two problems are important. If you solve them, then we can continue with the next part of the chapter. So we have one more problem to be solved by using the addition method. This is example 4 on page 306. So my system of equation now is not given in the standard form. So the equation need to be rewritten. So that's what we're gonna do. So we have equation 1, we have equation 2. So first we're gonna rewrite equation 1 in the standard form. So we have 2x equals 7y minus 17. I need to move this term to the left-hand side, so I'm going to subtract 7y from both sides of the equation. So I'm going to get 2x minus 7y equals negative 17. So that is going to be my first equation for the new system. So this is going to be my first equation for the new system. I need to rewrite also the second equation. I'm going to rewrite equation 2 in the standard form. So we need both variables on the left-hand side. So we have 5y equals 17 minus 3x. So now I need to move this term to the left-hand side. So I'm going to add 3x to both sides of the equation. So I'm going to write first x's. So I'm going to write 3x plus 5y. And this is going to be equal to 17. So this is going to be the second equation. So now my system is going to be written in the following way. So this is going to be 2x minus 7y equals negative 17. And 3x plus 5y equals 17. So now I'm going to start my process, so my method of addition. So I need to look for a variable to eliminate. So you can see now that I need to multiply both equations by different numbers in order to get opposite coefficients for one of the variables. We're going to cross multiply coefficients. You can multiply, for example, the first equation by the coefficient of x in the second equation, and the second equation by the coefficient of x in the first equation. So you multiply the first equation by 3, the second equation by 2, then you switch signs, and then you get opposite coefficients. Or you can do also the same thing with y. You have 5 here, so you multiply the first equation by 5. You have 7 here, you multiply the second equation by 7 and look for having opposite signs. So what I'm going to do is I'm going to eliminate x. So I'm going to cross multiply the coefficients of x. So when you need to multiply both equations, when you need to multiply both equations by different numbers, to eliminate one variable, then cross multiply by the coefficients of that variable and switch signs if needed. So cross multiply the equations by the coefficient of that variable. So let's do that with x. So we have here 2x minus 7y. I'm going to multiply this by the coefficient of x in the second equation. And this is going to be my first equation multiplied by the coefficient of x in the second equation. And I'm going to multiply the second equation, 3x plus 5y, by the coefficient of x in the first equation. So I'm just cross multiplying the coefficient of x, and later I'm going to need to switch the sign of one of the equations to get the opposite signs for x. But yeah, I'm trying to eliminate x, so I'm using the coefficients of x. So let's continue with the operation. So if we do this, we're gonna get, for the first equation, we're gonna get 6x minus 21y equals negative 51. And from the second equation, we're gonna get 6x plus 10y equals 34. So we're almost there. So now we have x with the same coefficient, but it's not the coefficient. I need the opposite signs on this coefficient. So I need either multiply the first equation by -1 or the second equation by -1. And multiplying by -1 means that you're going to switch the sign of every term that you have in the equation. So let's do that. So I'm going to switch the sign of every term on both sides of the equation. This is like multiplying by -1, so I'm going to get negative 6x, I'm going to get positive 21y, I'm going to get positive 51, and the second equation is written the same way, so I don't change the sign of the second equation. So do not change the signs in the second equation, only on one of the equations. Why? Because now you have x with opposite coefficients, so now we can eliminate x by addition. So we can just do this. We're going to get 31y equals 585. The final step is that we're going to divide by the coefficient of y. So that gives us 85 over 31. So we're going to get fractions sometimes, and we need to work with those fractions. So now we're going to do the back substitution. We need to back substitute this value into one of the original equations. So I'm going to do it into equation. Let me see what equation was this. 2x minus 7y equals negative 17. So I'm going to evaluate into the second equation. So I'm going to evaluate 5y equals 17 minus 3x. So that's the original equation 2. And we're going to evaluate this for y equals 85 over 31. So that means I'm going to replace y with 85 over 31. So this is going to be, let's see what equation I'm using. 5y, 7y. I'm going to use, okay. So I need to find x. So this is going to be 5 times 85 over 31 is going to be 17 minus 3x. So I'm going to need my calculator to do these operations. Some of the students like to use decimals. You are welcome to do that. I'm going to try to stick with fractions only. So let's see. So I need to solve for x now in this equation. So to solve for x, I'm going to need to subtract 17 from both sides of the equation. So I'm going to get 5 times 85. I'm going to write this first. 5 times 85 over 31 minus 17. And I'm going to need to multiply 17 by 31 to get the common denominator. So I'm going to get 5 times 85 over 31 minus 17 times 31 over 31, and this is going to be equal to negative 3x. So let's do these operations first. So we're going to get 5 times 85 minus 17 times 31. So this is going to be negative 0.102 over 31, and this is equal to 3x. And then we just divide by 3, by negative 3, both sides of the equation. So dividing by negative 3 is like multiplying by negative 1/3. Negative 1/3 that multiplies negative 102 over 31, and this is going to be equal to negative 3x over negative 3. So now negative divided by negative is going to be positive, and if you divide 102 by 3, you're going to get 34 over 31 is going to be equal to x. So now we have the solution that we are looking for. So we have a value for y, we have a value for x. So the solution is going to be 34 over 31 for x, 85 over 31 for y. And then you need to test the solution in the original system. So that's the problem. So I'm going to give you 4 more problems to work on, and then we're going to move on to the next section. So you're going to work now from the same exercise set from 4.3 exercise set on page 310. So you're going to work the following linear system. So you're going to solve the linear system by using the addition method. So the first problem is 2x plus 3y equals negative 16, 5x minus 10y equals 30. Then problem 20 is 5x plus 3y equals 27, 7x minus 2y equals 13. Then we have 24 is 5x equals 5y minus 8, and 3x plus 7y equals 14, and finally 26 is just 3x minus y equals 22, 4x plus 5y equals negative 21. So you're going to need to work at least on problems 18 and 24. So that's section 4.3. I'm going to give you time to work on these problems, and then we're going to start the next section. Section 4.4 starts on page 313, and it's about problem solving using system of equations. We're going to solve just one example. We're going to solve example 3, which is on page 316, and you have here the word problem, the corresponding word problem. So we're going to read the word problem. I'm going to increase the font size for you to read it better. So this is about fencing a waterfront lot. So you just purchase a rectangular waterfront lot along a river's edge. The perimeter of the lot is 1,000 feet. To create a sense of privacy, you decide to fence along 3 sides, excluding the side that fronts the river. We're going to need to see figure 4.12. An expensive fencing along the lot's front length costs $25 per foot. An inexpensive fencing along the 2 side widths costs only $5 per foot. The total cost of the fencing along 3 sides comes to $9,500. The first question is, what are the lot's dimensions? So you have here the figure 412. So you can see here that this is the river, and this is the lot, and this is the expensive fencing, and this is the inexpensive or cheap fence, and this is the other part of that, this fence with the cheap fencing. So we're gonna need to find the dimensions of this lot. So I'm just going to copy the problem into our notes. So let's see, I have copied the problem here, and also I draw the figure here. So you can see here that we have the expensive fence is here. I'm going to use X to denote the length of the expensive fence, and we're going to use Y to denote the side of the lot that is going to be fenced with a cheap fencing, and also this part is also using a cheap fence. So first we're going to use the formula for the perimeter. So you know that the perimeter is just the sum of the sides, the 4 sides, so that's perimeter. So we need to add X plus X, so this side, plus Y, and this is going to be the perimeter, which is just 1,000 feet. So that's the first equation to consider. So the perimeter of the lot. Now we're going to write an equation for the cost of fencing. So you know that the expensive fencing is $25 per foot. So we need to multiply this length by $25. So it's going to be 25x. So that is going to be the cost of the fence for the front of the lot. Then you need to multiply now this distance by the cost of the fence, which is just $5. So 5 times Y. And also, again, 5 times Y, because you have 2 sides measuring wide feet. And if you add up all the cost of the fencing, it's going to be $9,500. So I have here the equations, the result of translating the word problem into algebraic equations. Now we're going to just simplify these equations to get the system that we're going to solve. We have 2x, and we have 2y equals 1,000, and we have 25x, and 10y equals 9,500. So that's the system of linear equations that I'm going to solve to find the dimensions of the lot, because x is the length and y is the width. So this is equation 1, This is equation 2. We're going to use the addition method because this system is written in the standard form. Later, you're going to be able to use any method, the method of your preference. So you can see here that if we multiply the first equation by -5, I'm going to get y with different coefficients, opposite coefficients, so I'm going to be able to eliminate y. So I'm going to multiply equation 1 by -5 to eliminate y. That's the purpose of doing that. So I'm going to multiply the first equation. The left-hand side is 2x plus 2y. The right-hand side is 1000. You need to multiply both the left-hand side and the right-hand side by the same number. So in this case, you're going to get, applying the distributive property, you're going to get negative 10x, negative 10y equals negative 5000. So that's from equation 1. Then my equation 2 is just 25x plus 10y equals 9500. So now we're gonna add these two equations. So you get 25 minus 10 is gonna be 15x equals y is eliminated, so we get 9500 minus 5000 is gonna be just 4500. So the last step is just dividing by the coefficient of x, which is 15. So x, if you use the calculator, is going to be 300 feet. So now we're going to do back substitution. Back substitution into equation, let's see, we're going to use equation 1. So we're going to evaluate equation 1, which is 2x plus 2y equals 1000. And we're going to do this evaluation for x equals 300. So we're going to replace x with 300. So it's going to be 2 times 300 plus 2y equals 1000. So this is going to be 600 plus 2y equals 1000. Then we subtract 600 from both sides of the equation. So we're going to get 2y equals 400. Then we divide by 2. So we get now y equals 200 feet. So that's the solution. So the solution of the system, or the dimensions of the system, is just 300 feet, 200 feet. So that's the solution of the system. So now we're going to solve 2 more problems, and then we're going to continue with the last section for this chapter. So you're going to be able, you're going to be ready for your second exam. So I'm going to have a review session. I'm going to collect all the problems that you want me to solve. I'm going to prepare a video for you, and you're going to watch the review session. So you're going to be ready for your test number 2. So your assignment for this section is just 4.4. As I said, on page 324, you're going to work on problems 15 and 16. So I think you should have now your book, so you can check your book. But if you don't have your book yet, if you are still waiting for the bookstore to send you your book, I'm going to show you the problems. You're going to take a screenshot And then you're going to solve those problems. 15 and 16 are here. So those are similar problems. They are about rectangular lots. So let's see. You have here problem 15 and problem 16. You have the solutions also posted here, presented here, but try to get those solutions. So this is the last section of chapter 4 that we're going to cover, section 4.5. We're going to learn how to solve system of linear inequalities. You can see in the book an example of a system of linear inequalities. So we use the curly brace to indicate that this is a system, that these are not two independent linear inequalities. So these are inequalities that they are working together for some purpose. So, and you can have here the inequality symbols. So there is only one method to solve inequalities, which is the graphing method. So there is only one method to solve systems of linear inequalities, which is also the graphing method. So I'm just going to give you in a very, very simple way the steps. So this section starts on page 329, and I'm writing here the way that you are going to have the system of linear inequalities written. So this is the first inequality. This is the second inequality. These symbols are not used in these ways. This is just for you to understand that this is an inequality symbol and that the symbol can go in any direction. So this is the first inequality. This is the second linear inequality. We're going to use the graphing method. And what is the graphing method for this purpose? You're going to solve each inequality by graphing. So you're going to get the solution for the region for this inequality. Let's say that you're going to get, this is the boundary line for the first inequality. And then after you test the origin, you find that the region to the right of this line is the solution for the first inequality. Then you do the same thing with the second inequality. Let's say that this line now is the boundary for the second inequality. You have two regions, you test the origin, you find that now this is the region, the top one, for the second inequality. Then the solution for the system is where these two solution regions intersect or overlap. So you're going to see that only this region here contains both the solution for one inequality and the solution for the other one. So this is the overlapping region. So only the overlapping region is going to be the solution for the system. This is like equivalent to finding the intersection point when you are working with lines. So this is the intersection point. But when you are working with inequalities, you are finding the intersection of areas, so shaded areas. So we are looking for the overlapping shaded areas. So that is going to be the solution for the system. So this is just more of the same. So I'm going to work on one problem for you, and then you're going to have two more problems to work on to complete the assignment for this section and to finish the chapter. So I'm going to work on example number 2. So this is example number 2. Is on page 330. So we're gonna graph the solution set. Graph the solution set of the system of linear inequalities defined by the following inequality. So 2x minus y less than 4, x plus y greater than or equal than -1. So this is the system of linear inequality. So this is my first inequality. This is my second inequality. So we're gonna start graphing the first inequality. So we're gonna find the information. We're gonna graph inequality 1. So we're gonna graph 2x minus y less than 4. So what is the first step when you are graphing an inequality? We're gonna find the boundary equation. So we're gonna find the boundary. How do you find the boundary? You just need to write the left-hand side of the inequality, then an equal sign, and then the right-hand side of the inequality. So now you have an equation. So this is the equation of the boundary. And also, you can see here that you have a symbol that indicates that this is an open boundary. So you're going to use a dashed line for this open boundary. So now we need to find the graph of this line. So we find the boundary and we plot the boundary. So we're going to need to find the intercepts. So 0, 0. So if x equals 0, so you just need to remove or hide 2x, and you read negative y equals 4. So if negative y equals 4, then you just switch the sign or divide by negative 1 both sides of the equation, so you get y equals negative 4. So the first intercept is negative 4. Then when you set y equals 0 to find the other intercept, you just need to hide negative y, and you read 2x equals 4. 2x equals 4, then you divide by 2, because that's the coefficient of x, so you get x equals 2. So that's the other intercept. So now we have 2 points for the first boundary. So these are the points. Once you find the boundary, you need to test the boundary to see what is the solution region for the first inequality. So you're gonna test 0, 0. You test the origin for the first inequality, which is you're gonna evaluate 2x minus y less than 4. That's the first inequality. 4x equals 0, y equals 0. So that means that you have 2 times 0 minus 0 less than 4. So you get 0 less than 4. This is true. So for the first inequality, 0, 0 is inside of the solution region. Inside of the solution region. So we finish everything that we need for the first inequality. Now we're gonna graph. We're gonna get the information to graph the second inequality. Just gathering the information. We're gonna plot everything later. So the second inequality is x plus y greater than or equal than negative 1. So we're gonna find again first the boundary. So find the boundary for this inequality. So you're gonna write the left-hand side, then an equal sign, then the right-hand side. So now we have the equation for the boundary. So in this case, you see that you have the equal sign embedded. So this is a closed boundary. So we're gonna use a solid line for this closed boundary. We're gonna use a solid line. Now we need to find the intercepts again. Now for this equation, so we have 0, 0. So if x equals 0, use high x, you read y equals -1. So y equals -1. So you write here -1. Then if y equals 0, now you gonna hide y, and you're gonna read x equals -1. X equals -1, so you have here -1. So now we have the intercept for the other boundary. We only need to check the origin for the second inequality. Let's see. So we're gonna test the origin. So we're gonna evaluate the second inequality, x plus y greater than or equal to -1 for x equals 0 and y equals 0. So this is 0 plus 0 greater than or equal to -1. So is 0 greater than or equal to -1? That is also true, because 0 is greater than any negative number. So that means that in this case, the origin is also inside of the solution region. So now is the time to put everything into a grid paper. So let's do that. So we have here first for the first inequality. Let's work with the first inequality. So I have first, I need this information for the boundary. So I have here point 0, -4 to 0, and also a dashed line. So let's do that now. So we have 0, -4 is -1, 2, 3, 4. So that's 1 point for the first boundary, and the other one is 2, 0. So this is 2, 0. So these are the 2 points defining the first boundary. The first boundary is open, so I need to draw a dashed line. So you draw a dashed line. So that's the first boundary. Remember, anytime that you have a boundary, the boundary is dividing the plane into regions. One is going to be the solution region, and the other one is not going to be the solution region. So to know what is the solution region, we need to test the origin, and we need to see whether the point is inside or outside. So for the first one, we found that the origin is inside the solution region. So for the first inequality, we found that the origin 0, 0 is inside of the solution region. So that means that the origin is here. So this region is going to be the solution for the first inequality of the system. So this region satisfies 2x minus y less than 4. Now we need to check the information for the other inequality. So we found that the points defining the boundary line are 0, -1. So I'm going to write here 0, -1 and -1, 0. So these are the 2 points that define the boundary, and it's also a solid line. So I'm going to have here that this is going to be a solid line. So I'm going to find these 2 points now. 0, -1 is going to be here, and -1, 0 is going to be here. So I have now these 2 points defining the other boundary for the other inequality, and this is going to need a solid line. So a solid line is going to be this line. This is the other boundary. Now, again, if you forget about the other inequality and just focus on this inequality, this region is divided into parts. This is the boundary that you're going to take into account now to find the solution region. And you can see now from the problem that in the second case, when you tested 0, 0, you found that also the origin is also inside of the solution region. So that means that in our plot, now looking at this boundary, this is going to be the solution region for the second inequality. So this is going to be the solution region. And this is the solution for the first inequality. So you can see here where the overlapping region is. So again, this is going to be for the second inequality, x plus y greater than or equal to -1. So this region satisfies this inequality. This region satisfies the other inequality. And this region here, the one I'm going to shade completely. So this region here satisfies the system of linear inequalities. So in this region, the system is satisfied. So you can write here 2x minus y less than 4, and also x plus y greater than or equal to -1. So the system, both inequalities are satisfied in this region here. So that's the solution of the system. So finally, you're going to work in one example, in one exercise from the corresponding exercise set to finish the chapter. So you're going to go to 4.5 exercise set on page 333, and you're going to solve the inequality, the system of inequalities, 3x plus y less than 6, and x plus 2y greater than or equal to 2. So solve this system of linear inequalities. Take the screenshots of all your work from this lecture that unfortunately we needed to interrupt because of broadcasting issues, but now you have the final part of the video. So compile all your work, take screenshots, use an app to convert everything to a single PDF file, upload your work, and be ready for the, you can now take quiz number 4. You can also solve quiz number 4, homework 4, and you are ready for test number 2 that is going to cover chapters 3 and 4. So I'm going to have a review session the next time, so I'm going to collect all the problems that you're going to submit. You're going to send me by email to include in that review session.